We went to use the rational zeros theorem to find all zeros of a polynomial, and we're given a function that we're told has at least one rational zero, and it's a third degree polynomial. So if I can find the one rational zero, I reduce it to quadratic, and then I can use the quadratic formula to find the others. So my options here are plus or minus 1, plus or minus 7, because those are the factors of 7 over 1, plus or minus 1/2, plus or minus 7/2, plus or minus 1/3, plus or minus 7/3, plus or minus 1/6, plus or minus 7/6. So I have both 1 and 7 over 1, 2, 3, and 6. So those are the factors of 6 in the denominator. Now, that's a lot of factors to have to check, but the only way is just to start checking. I'm going to begin with plus or minus 1 because those are easy. I can just add the coefficients to check 1, because if x is 1, then this is just 6, this is 43, this is 6, this is negative 7. And 1 doesn't work. I can do that in my head. Negative 1 would be negative 6, positive 43, negative 6, and negative 7. That also doesn't work. I don't know what that sum is. I just know that positive 43 is a lot bigger than negative 6, and negative 7. So you can divide those out if you need to. Otherwise, you don't need to. I'm going to use Descartes' rule of signs here to make a little limitation, I think. This has at most one positive real zero, but h of negative x would be negative 6x cubed plus 43x squared minus 6x minus 7. So 1, 2 sign changes. It has 2 or 0 negative roots, but has at least one positive root. Of course, the positive root might be irrational. So the next step is just start trying. I'm going to try negative 7. This is 6 and this is negative 42. And you can see why I started with negative 7 instead of positive 2, because that gives me a 1 here. Negative 7, negative 1, positive 7. So my intuition there was good, because the leading coefficient and times negative 7 was negative 42. Negative 7 seemed like a good thing to try. And that leaves me with 6, 1, and negative 1. So this is 6x squared plus x minus 1. And that actually factors into 3x, 2x, and then this will be minus 1, and this will be plus 1. If you can't see those factors, then just use the quadratic formula. So I'd have negative 1 plus or minus the square root of 1 plus 24 all over 12. And that would be, or that is negative 1 plus or minus 5 over 12. And negative 1 minus 5 over 12 is negative 1/2, which is that root right there, or gives me the same root as that right here. And negative 1 plus 5 is 4 over 12, which is 1/3, which corresponds with that right there. And then be sure to state all of your zeros, right? All of the zeros. It's a third degree polynomial function, so it has 3 zeros. Don't forget this one. So the answer is negative 7, 1/3, and negative 1/2. And Descartes' rule of signs didn't eliminate anything because I have 2 negative zeros and 1 positive. I don't have any irrational zeros.